Okay, hello everyone. I am Dávid Márk Nemeskey from the National Laboratory for Digital Heritage. And yes, as you could hear, I would like to talk about the kind of AI tools that we are developing at the laboratory and what we are using them for. So first, a few words about the laboratory itself. So DH Lab, for short, Digital Heritage, is one of the original 18 national laboratories that were created in 2020, I believe. And it is actually a consortium with 4 members. The Department of Digital Humanities at the Eötvös Loránd University acts as the leader of the consortium, but it also includes the Institute for Literary Studies, the National Archives of Hungary, as well as the University of Miskolc. Actually, it is one of only 2 national laboratories in the fields of humanities. So all the rest are basically realities or hard science. Right, so the main goal of the laboratory is to preserve our digital heritage and also provide, well, open and intelligent access to it. And we'll see what I'm talking about soon enough. We have several projects, such as Digifil with IT. We do also publish literary corpora. We are harvesting news items, complete with all kinds of metadata and archiving them. And there are other projects as well, the Danube AI project and so on and so forth. I am not going to talk about these projects. What I would like to talk about instead is the AI tools that we are developing and the kind of new cultural or professional practices they entail. So first of all, probably the most important at this point is large language models. Ever since ChatGPT has appeared, everybody understands how important it is to have an LLM. So, of course, we had to have it as well. I would like to talk about semantic technologies for distant reading and also how to process text and what we use it for. And finally, also how we create annotated training corpora for different AI and NLP systems. Right, large language models for Hungarian. As we all know, LLMs basically form the basis of modern NLP. So tasks and so NLP, natural language processing for short, but also for natural language understanding. So there are tasks that 6 years ago were completely unapproachable by natural language understanding systems, question answering, proper summarization and so on come into mind, but are now, we know that there are systems that can even surpass the average human performance on some of these tasks, at least. So the main stake that we have in the LLM business is the GPT-3 project of the Ministry of Innovation and Technology and OTP, the largest Hungarian bank, which aims to release Hungarian LLM models about the size of 13 billion parameters, which is not huge, but we only have, so many documents to learn from. So it's we don't have the Hungarian as a language doesn't have the resources that English has. Now, in this project, it fell to us to compile the training corpora. And also, once we have the training corpora, we can, of course, experiment with different models themselves. So we are experimenting, for instance, with RetNet, which is a new model architecture that could at one point replace the transformer that underlies all LLMs at the moment. And we are doing that in conjunction with the Faculty of Informatics at Eötvös Loránd University. Right. So what kind of training corpora are we talking about here? So the first one that is needed for an LLM is basically the corpus that so the first step of training a large language model is so-called pre-training, which basically means that the model just reads as many texts as it can get. And this is what we did at this point, to compile a huge corpus, about 40 billion words, from web sources like Common Crawl, news outlets, and various repositories, such as academy, court decisions, parliamentary proceedings, and so on and so forth. And this is what we were working in like the last 2 years. And now we have moved on to benchmarking, because once we have the model, of course, we want to know how good it is. And the point is, once again, there are a plethora of benchmarks for English and not so much for Hungarian. Basically, we have 0, so, or 1. So we made it our business to translate a few, and we have human annotators working on them, but we also provide machine assistance to them, so basically machine translation. We provide a machine translated baseline to them so that they don't have to start from the beginning. Right, but that's enough of how to assist the machine. Let's talk about how to assist humans, in this case, in distant reading. This is, of course, the term comes from Franco Moretti, and in today's environment, we could imagine what it means is that we can, with AI tools, we can provide a similar literary experience for the reader than what they would get when reading something that belongs in the literary canon, meaning summaries, different kinds of annotations, and other analysis. But we want to have that for all kinds of text. And the solution that we well, not came up with, but that we are using for that, is the Who-Wikifier software, which we have developed. Wikification is basically the task of looking up Wikipedia entities in a text. And this is, of course, very useful for a human just reading the text, because if they encounter something that they don't understand, or at least a name that they don't know nothing about, they can just look it up with a click of their mouse. Also, it's very useful for collections as well, because once documents in a collection are annotated with these entities, it suddenly becomes very, very easy to look up which texts contain a particular entity, for instance. Now, the original algorithm that we started out with was, so there was this system called Wikifier, and we based our implementation on the original paper of that. This is based on Wikipedia's link graph, and it's kind of has a 2000 feeling to it. And right now we are working on introducing deep learning-based entity linking into the system, so to improve its quality. And this is not all we are doing. The original system was set to be language agnostic, and mainly it is, of course, but Hungarian does have a few peculiarities, for instance, agglutination, that made it very important to cater for. Basically, if you don't handle that, then you won't find all the entities if, let's say, they don't appear in the text in the exact same form as they did in Wikipedia. So yes, this is just one example. Of course, the UI is very basic, because this is just a testing UI, but we also have a REST endpoint which is used by our partners. Now, So if we have a digitized text, of course we can do that. What if we don't have the text digitized as of yet? So let's say we have documents. We all are also digitizing documents, but when we were compiling this training corpus for LLMs, in many cases, in the repositories, what we have found is that there are PDFs, but the PDFs don't contain computer-readable text. All they did is scan the PDF and put it up. And in this case, what we need to do is have an optical character recognition to arrive to computer-processable text. And this is exactly what we have done. We used a Tesseract 4. It's an open source program available from GitHub. It has built-in models for more than 100 languages, but also what is very important is that the model could be trained further. And this is actually very useful because when we first tested it on these documents, what we have found is that the original model had about 10% character error rate, which translated into 26% word error rate. What this means is that every word, one word out of every 4 was recognized incorrectly. Of course, this is not the quality that we aim for. So what we did is we used a natural language processing pipeline to find all the sentences which had nonsense words in it. And then we compiled a training corpus of like 93,000 such sentences, and we manually annotated them. We fixed the character recognition, and then used this training corpus to fine-tune the model. And as you can see, we could bring down the character error rate to 1/4 its original value, and the word error rate to 1/3. So this is still not the quality probably that we are aiming at, but it makes it much easier for some post-processing based on like a BERT-like language model to actually fix the remaining issues. Yes, so that was one part of the written word, but what if the written word is actually written, handwritten, as in longhand? It's a different kind of problem, but something that we also had to tackle. And so we had 3 corpora, which I will introduce in the next slide, on the next slide. And once again, we chose a similar solution. We used TR-OCR, which is an open model. It had, once again, a pre-trained model that could be trained further, fine-tuned further. And this is exactly what we did, but we didn't stop at this point. So this is a project that is more or less done. We have also created a web service from it so that, once again, researchers could access it via a REST endpoint, and also a demo page is included as well. I don't think I will have time to show it, but it is there. So the corpora we tested it with so the first one is the correspondences and official documents of one of our greatest poets, János Arany, and then we had the Rerum Ungaricum Libri Corpus, and we also had certificates from the National Archives of Hungary. And we compared our results with that of Transcribus, which is the software used most in research. And what we have found is that for the smaller corpora, we are kind of on par with Transcribus, but for the larger ones, we actually outperformed it by about, 35%, I guess. And this is also a model in which we, once again in cooperation with the Faculty of Informatics, we improved it via including syntactic data as well. Right, of course we have written word, but we also have spoken word. And this is once again part of our digital heritage. This is a project in progress. We are at the starting steps. We have 2 speech corpora that we would like to transcribe. One comes from the Institute of Ethnography and Folklore, and the other one comes from the official, unofficial, I don't really know, radio of Eötvös Loránd University called EPER radio. And once again, we chose a similar path as to OCR and head-written text recognition. We basically took an open system. In this case, it's OpenAI's Whisper as our base model, and we have plans on creating, once again, an annotated training corpus and fine-tuning it. And whoever knows Whisper might actually ask, why is it necessary? Whisper is good enough as it is. But what we have found is it might be true for English, but not really for Hungarian. So for Hungarian, we have about 17, actually. Yeah, okay, so 17% word error rate. But actually, when we tested on some of the speech corpora that we are talking about, it's more like 29%, I think. So it's very, very high. But anyway, even if it's 70% is not enough, we are not at the same level as, say, Korean or Romanian, and certainly not at the same level as English. And also, so we, of course, want to fine-tune it further, but we also want to experiment with putting regular language models after it, because Whisper doesn't have that, and it's very clear to see that many of the errors it makes could be fixed with a very easy language model. The other problem with Whisper is, of course, that it has no diarization. So it transcribes the spoken utterances into text, but it does not assign them to the different speakers involved. And hence, what we are working on right now is introducing speaker ID before sending the segmented text to Whisper for language identification and transcription. Okay, finally, that's enough about how to assist the machine. Let's talk about how to assist the humans that make the machine. Because we are talking about AI and how AI has made everything much easier and so on and so forth, but the truth of the matter is that we still need manual work, and quite a lot. So, for instance, manual annotation is needed for fine-tuning, and fine-tuning is needed to achieve the kind of quality that we are aiming at. And we are lucky in that we have 5 annotators. One of them, incidentally, is part of the organizing crew of this conference. And we aim to support them by creating a custom web UI, which then can help them in their work. We actually have a framework which is kind of modular, so we could adapt it to different tasks, such as boilerplate removal, translation, and OCR correction. And we are also thinking of adding another module for speech to text. And this is an example. As you can see, this is for translation. So the input document had different fields. One is called input, then A, B, C, D. Okay, so it's not, and so input contains only one paragraph. What are 2 examples of an evaluation of outcome? And the annotator can just translate it by hand or hover over the original English paragraph, and then they actually provide them machine-translated baseline, which they can copy and work and fix, and also provide a translation memory, which is not shown because this is the first time that we have seen this sentence. So that concludes my presentation. I think the main takeaway is that AI is very good, and I can join in the previous presenter, I don't know where he is, that we have to use it, but we also have to assist the humans that are working on said AIs. Thank you very much.